Hello students at home, welcome again to our online lesson. They say work without play makes Jack a dull boy. That's why I decided to start today's lesson with some good moves so that you can see your teacher also can do some dance moves. Today we are continuing with where we left on matrices, and today on our topic on matrices we're going to look at determinant and inverse. Determinant and inverse of a matrix. In my previous lesson, you can check on the previous YouTube videos which I've uploaded. I've talked on how to multiply matrices and order of a matrix. So in today's topic, we'll be specifying or we'll be looking mainly on how to calculate determinant and inverse of a 2 by 2 matrix. We said matrix have orders. If we talk of 2 by 2, it means it has 2 rows and 2 columns. So an example, we'll start with determinant. And I'll take a matrix A, B, C, D. This is a 2 by 2 matrix. So to get a determinant, a 2 by 2 matrix has 2 diagonals. We have diagonal AD. Diagonal AD is called a leading diagonal. It's a leading diagonal. Then we have diagonal BC. Diagonal BC is called a secondary diagonal. Secondary diagonal. So in a 2 by 2 matrix, we have those 2 types of diagonals. So when you have the 2 types of diagonals, now it's easier to calculate the determinant. You take the product of the leading diagonal minus product of the secondary diagonal. So determinant, DET, equals to AD minus BC. AD is A times D, BC is B times C. And that's how you get determinant. Let's take an example. We can have a first example of determinant. We can have a matrix 3, 5, 2, 4. 3, 5, 2, 4. So what will be the determinant? Determinant will be leading diagonal minus secondary diagonal. Leading diagonal is 3 and 4. So you take the product of leading diagonal, which will be 3 times 4. That gives you 12 minus product of the secondary diagonal, which is 5 times 2. That should give you 10. 12 minus 10, and the determinant will be 2. So that's how you just calculate the determinant. So when you're at home practicing your social distance, self-quarantine, sanitizing, you can attempt these 2 examples. You calculate the determinant. The first one you can do if you have 3, -5 and 2, -2. That's matrix A. Get its determinant. Another matrix which you're supposed to get determinant, you can have -4, 6, and -3, 2. Those 2 matrices. Try to, as you do your practice, you can get their determinant. So let me just do a review of what I've talked about on determinant. You first have to identify the 2 diagonals. That's the leading diagonal and the secondary diagonal. That's AD and BC. Then to get the determinant, you do product of the leading diagonal minus product of the secondary diagonal. AD minus BC. Easy as that. And you get your determinant. With the determinant, now we can move to inverse. Inverse of a matrix. inverse. And I'll take the example of a matrix A, B, C, D, where A, B, C, D stand for any integer or value. So if you want to get the matrix of A, B, C, D, first step is to get the determinant, of which determinant will be leading diagonal AD minus BC, leading diagonal minus secondary diagonal. After getting the determinant, you take the digits in the leading diagonal and interchange them. So the inverse now will be equal to, first I divide the matrix by the determinant, which to divide is just to say 1 over AD minus BC, where AD minus BC is the determinant. Then you open bracket, you interchange the values in the main diagonal, in the leading diagonal. So D comes here, A comes here. Then the values in the secondary diagonal, you interchange them. You interchange the values in the secondary diagonal. So you don't interchange, you change the sign of the values. So if it's B, it becomes negative B. If it's C, it becomes negative C. And that's how you get the inverse. When we take a specific matrix, it will become easier. Maybe it might be confusing because of the letters, but now when you take a good example or a real matrix where we don't have letters A, B, C, and D, then we are able to calculate the inverse. Main points to note: the numbers in the leading diagonal, you interchange them. The numbers in the secondary diagonal, you change their signs. If it's negative, it becomes positive. Let me do an example of inverse. Let me take a matrix here. We have minus 5, minus 3, minus 2, minus 2. This is A. Let me call it matrix A. Then you are told find 8 power negative 1. 8 power negative 1 means inverse of A. In short, they're asking to get the inverse of A. So to get the inverse, you have to start with determinant first, of which determinant will be equal to product of leading diagonal, negative 5 times negative 2, that should give you 10, minus negative 2 times negative 3, that should give you 6. When you subtract, you get 4. After getting that, now you say A to power negative 1 will be the same as 1 over 4. When you take 1 over 4, it means you're dividing by 4. Bracket, what do we do for the leading diagonal? We interchange. So negative 2 comes here, negative 5 comes here. The ones in the secondary diagonal, you change their sign. So negative 3 becomes 3, and negative 2 becomes 2. Then you just leave your answer in this form. 1 over 4 brackets, negative 2, 3, 2, negative 5. 1 over 4, I'm still insisting, it means you are dividing each number by 4. Each number by 4. I hope that example is clear. If it ain't clear, I'll do a second example where we want to calculate the inverse. This is matrix A, its inverse is this. Let me take matrix B and we calculate its inverse. So B equals to 3, negative 5, 2, negative 2. Find B to power negative 1, which is the same as the inverse of B. First step, get the determinant. Determinant is product of leading diagonal minus product of secondary diagonal. Leading diagonal is 3 times negative 2. That will give you negative 6. 2 times negative 5, that will give you negative 10. So it will be minus 6 minus negative 10. With your calculator at home, when you work out, this should give you 4. Negative 6 minus negative 10, that should give you 4. Then what do? The numbers in the leading diagonal, we interchange. So the inverse, b negative 1 will be the same as you take 1 over 4, because 4 was the determinant, brackets, negative 2 comes here, 3 comes here. These two change their sign. Negative 5 becomes positive, 2 becomes negative 2. And that's the inverse of that matrix. That's the inverse of the matrix. So that's how you calculate the inverse. Another thing we want to see what's the product when you multiply a matrix by its inverse. What's the product when you multiply a matrix by its inverse? So I'll take this b. We want to do b times b power negative 1. If you multiply b and its inverse, what do you get? So this is my b. I'll write my b to power negative 1, or the inverse of b, which is negative 2, 5, negative 2, 3, brackets 1 over 4. So we want to multiply the matrix b and its inverse and see what kind of product we get. So in our previous lesson, we had looked at how to multiply matrices. You multiply rows with columns. Rows with columns. So I'll take this row of 3, negative 5 and multiply with the column of negative 2, negative 2. So how do you multiply? 3 times negative 2, that's negative 6. Negative 5 times negative 2, that's 10. Then you do negative 6 plus 10, which gives you 4. So you get 4. Same row, multiply now with the second column of 5, 3. 3 times 5, 15. Negative 5 times 3, negative 15. 15 plus negative 15, that gives you 0. We are through with the top row. Let's move to the lower row of 2 minus 2. Same row will multiply with this column and this column. So let me start with this column. 2 times negative 2, that's negative 4. Negative 2 times negative 2, that's 4. 4 plus negative 4, that gives you 0. Same row, multiply now with the column of 5, 3. 2 times 5, 10. Negative 2 times 3, negative 6. 10 plus negative 6, you get 4. There was that scalar quantity 1 over 4. 1 over 4 means you divide each number by 4. So when you divide each number by 4, you'll get this matrix 1, 0, 0, 1. This kind of matrix is referred to as identity matrix. Identity matrix. So when you multiply a matrix by its inverse, you get what we refer to as an identity matrix. And an identity matrix, in matrix, it behaves like number 1. Any matrix being multiplied by an identity matrix will remain the same. If I take this matrix B times this matrix, it remains 3, negative 5, 2, negative 2. Nothing changes. So it's this kind of matrix behaves like matrix number 1. So with those 2 examples, or those 3 examples which I've touched on determinant and inverse, I'm sure you have learned something even when you're at home. And I'll give you 3 questions which you can also try to do on calculating inverse. Find the inverse. Find the inverse. And the first one will be 8, 7, 7, 6. B will be negative 2, negative 2, negative 2, negative 5, negative 4. And C, 5, negative 3, 4, negative 2. So you can attempt to do those 3 questions or those 3 exercises. And I hope the lesson today has been of important or productive to you, and I'm urging you to share with friends and tell them to subscribe to my YouTube channel, Alan Yonga, and also to watch me on KU TV on Tuesdays and Thursdays for more maths and chemistry lessons.